So 7.2, this is all about linear inequalities. We're going to talk about solving these, or really more accurately, how to represent solutions of them. So when I say a linear inequality, I really mean something like the following thing. I don't know. Something like this. So we're always going to have two variables. Well, maybe, might just have one variable, but often we'll have two variables, x or y, and I'm going to put everything together in a nice expression, but instead of an equal sign, we'll have an inequality symbol. So it could be something like that, or it could be, I don't know. I could use the other kind of inequality symbols. So I could have the less than or equal variety, or I could just have a greater than or less than with no equals. These are the only two sort of flavors of inequality that we're going to deal with. But so these would count as inequalities. Again, maybe I'll only have one variable, maybe I'll have two. I don't think we're going to have more than that in this class because eventually we're going to be graphing these, and graphing with more variables would be too difficult. So these are the kinds of things that we're going to mess around with. And so you should remember where these came from in the last section. So just to recall, why do we care about these? The constraints of our linear programming problem are inequalities. They are linear inequalities. Maybe a better way to say this would be that our constraints for our linear programming problems are just a system of inequalities. It's a bunch of inequalities grouped together. And so really, that's something we're going to have to learn how to deal with, and we're going to do that in this section. So somehow, to solve our linear programming problems, I have to deal with this system of inequalities that are the constraints. And so we're going to learn how to deal with solving systems of inequalities in this section, because somehow that'll help us solve our linear programming problem. Okay, so here's how we're going to deal with this. I'm going to leave one of these on the board as just for a second to illustrate a point, which is, what are solutions of this? I mean, how many solutions does this inequality have? Maybe that's a good question. How many solutions does this have? Well, what do I mean when I say a solution for an inequality? Well, we have two variables, x and y, so I'm asking for values of x and y that together will make this a true statement, right? So, I want to solve this. Let's find the x and y that makes this true. Well, for example, I don't know, if x equals -4 and y equals 0, what happens? If x is -4, I'll get -8. If y is 0, this goes away, and then I have -8 is less than or equal to -4. Is this a true statement? Yes, this is true. So -4, 0 is a solution. So I know there's at least one solution. Are there more? Well, sure. I mean, make this, I don't know, more negative. What about like x is -10 and y is 0? I can put really big negative numbers here and put 0. I think it'll just make this even more negative, so it'll still be true. So it'll be more solutions. Maybe here's another solution. What if x is, I don't know, 0 and y is -1? We'll put in 0. I'll get -5. -5 is less than or equal to -4, so this is a solution too, and so forth. It turns out I could just keep going, right? And in the end, as is often going to be the case with these, there are infinitely many solutions. There are infinitely many. Pretty much any of these that I write down in this class, there's going to be infinitely many solutions for these. If we think way back to the beginning of the semester, when we were graphing lines, when I gave you just linear equations instead of inequalities, just straight up equations, we had the same situation. I gave you an equation with two variables. There were infinitely many solutions. And so we had this problem of like, how do I write the solutions down? How do I communicate the solutions to someone else in some intelligible way? Because there's infinitely many of them, so I can't like list them out. And so turns out that we're going to treat this just like we do with equations, where instead of trying to write down the solutions, we're going to graph instead. So we're going to draw a graph that will represent solutions to an inequality, much like we did with equations. But there'll be one extra sort of step we have to do because inequalities are just different from equations, right? I'm saying that this side and this side might not be equal. This might be less than the other side. So we have to deal with that somehow when we graph. And so that's what we're going to do. Okay. So there's our motivation for why we're going to graph them. so we could represent to infinitely many solutions. And of course, we want to be able to graph them because somehow we want to use these to solve our linear programming problems. Okay. So basically, I want to outline the strategy for representing the solutions by a graph. And the best way to do that is by an example as I go. So here's our strategy. And along over here, I'll have sort of an example to play with. We're going to graph one inequality. It'll be this. How about, let's see, I've wanted a particular one. How about 2x minus y less than or equal to, I don't know, -1. Okay, 2x minus y less than or equal to -1. It's a simple linear inequality of two variables. We're going to find out how to graph this to represent its solutions. Again, there should be infinitely many solutions. Let's see what they look like on a graph. So here's our overall strategy. Step one is we're going to graph a line. We're going to graph the equation corresponding to the inequality. So what do I mean by that? What I mean is this is a nice inequality with two variables. If I turn this inequality symbol into an equal sign, I get an equation instead. And then it's just a linear equation, which we already know how to graph because we did that in chapter 5. So when I say graph the corresponding equation, I mean turn this into an equal sign and then graph the line that you get. Yeah. So that's what we're going to do. So I'm going to start drawing my graph over here. And if I turn this into an equal sign, what is my line? It's 2x minus y equals -1. If you like, I could basically solve this into slope-intercept form, and I think I'm going to get y equals 2x plus 1. So you can think of turning this into an equal sign and add y to both sides, and then add 1 to both sides. I'm going to get y equals 2x plus 1. That'll help me graph it. Again, the alternative way would be just turn this into an equal sign and then find like your x and y intercepts and graph it that way. It's sort of up to you to choose. I prefer, I'll just put it in the slope-intercept form and graph it that way. So we do that. So my y-intercept is 1. My slope is 2. So when I go to the right by 1, I should go up by 2. And so here's my line. Okay. Now, I was a little, I don't know, quote unquote, sloppy about one detail here. And I'll get to that with another example later. So for now, I'm going to press on. So far, we're good. And I'll come back to a little detail later that'll be important. But in this example, it actually doesn't matter. So we'll just continue. So far, we're good. So step 1, graph the corresponding equation. Step 2, we're not done, because one thing to check is, are the points on this line solutions? So take something that satisfies this equation. I don't know, what about the y-intercept? That's 0, 1, right? That's 0, 1. If I take 0, 1 and plug it into this inequality, do I get a true statement? No, that's a point on the line. Let's plug it in. Plug in 0, 1, I'll get 0, and then -1. I'll get -1 less than or equal to -1. Is this true? Yes, it's true. Because I get equality, -1 equals -1, and this is less than or equal to. That was a point on the line, and I got a true statement. Turns out if I take any point on this line, I will get a true statement in the inequality if I plug it in. The reason being that every point on this line satisfies the equation, and the sign that I'm using here is or equals, it's less than or equals. So if you're equal, you get a true statement. So every point on this line is a solution. But the question is, are there more solutions? Is this the only, are the only solutions to this inequality on the line? And the answer is no, there are more. And so here's what we need to do. We're going to test a point not on the line. So we're going to pick some random point that's not on our line, and we're going to test it by plugging it into the inequality. And if I get a true statement, shade where that point was. And if false, so if I get a false statement, shade where point is not. And I'll make that really clear what I mean. So what I really mean by this is, let's take a point that does not lie on this line. So for example, I don't know, 1, 0 is right here. That's 1, 0. And it's not on my line, right? You can see on the graph, it's not on the line. So this is a good candidate point for me to check, to test out. And so what am I going to do? I'm going to take 1, 0, and I'm going to plug it into my inequality. And what's going to happen is I'm either going to get a true statement or a false statement. Now notice the line kind of cuts the plane into 2 pieces, right? There's this piece over here above the line, and there's this other piece over here below the line. It's just like cuts the plane in half. And it has 2 sides. The point is that if I get a true statement when I plug in this point, then I'm going to shade this entire half of this plane where this point is. Because it turns out that if this point satisfies the inequality, every single point on this side of the line also satisfies that inequality. On the other hand, if I plug this in and I get a false statement, then this is the wrong side. And it turns out all my solutions are actually on this side. And so I should have to shade everything on this side of the line. Okay. So I will do a few more examples after this one to make it clear. Let's go ahead and finish this one off. Let's test our point. Let's plug in 1, 0. So I plug in 1 for x, I get 2. I plug in 0 for y, that's just 0. And so I have 2 less than or equal to -1. And that, of course, is false. 2 is not less than or equal to -1. 2 is greater than -1. So that's false. Since our point was on this half of the line, or this half of the plane, and I got a false statement, I should instead shade the other side, because this is the wrong side. The solution's not over here. If I pick anything over here, I'll get something false. So it turns out I need to shade everything over here. So that's what we're going to do. So pretend I shaded off forever this entire half of the plane above the line. Then this line, including all this blue shading, is our solution. Those are all of our solutions for this inequality. This is how we represent it. Okay, so this is a good point to pause first, just to point out that when you guys work on these on your activity and you have to submit written work, if you don't happen to have, if you have colors like colored pencils or crayons or something, please use them. It'll really help, especially once we do systems and there's multiple of these. It'll really help clarify what is what on your graph, so it's easier for us to grade and interpret what you're doing. And also, if you don't have colors, then just shade carefully and make sure you make really clear where your solution is. So I'm going to harp on that again when we do a system, but I just want to point that out now. Anyways, it's a good point to pause and ask if anyone has any questions at this moment. Okay, see, it feels like a no. Okay, let's do another example. This is basically our overall strategy. So we're always going to represent a solution to a single inequality by a line and some shading, and that's it. So I don't know, let's pick one like this.